Hello and welcome to Scholar Fedu. This is our JAMB prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we're looking at the UTME questions for chemistry for the year 2017. This is the first part of the recording. We are going to look at the first 20 questions out of the 40 questions for the year. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam and modular quizzes for free. Alright, first question here. The flame used in welders in cutting metals is, that is the oxyacetylene flame. Okay, the oxyacetylene flame is used by welders in cutting metals. Okay, so at room temperature, that's 300 Kelvin in this diagram, in the diagram below. So we have to basically validate this here. Okay, this option, which one of this option is correct. Now if we look at the axis here, this is 273, this is 283, 293. See that there's a difference of 10 here. Here too we have a difference of 10 to 20, 20 to 30 to 40. So we have a difference of 10 as well here. Now so here is this a graph of solubility against temperature. If we look at 300 degrees Celsius, okay, 300 Kelvin rather, if we look at 300 Kelvin here and we trace it up, we see that the solubility of X at that 200, which is about here, is 20. Okay, it's like say 20, while the solubility of Y at that same temperature, we trace it up to this line for Y, you see it is about 60 here. Okay, it's about 60, not exactly 60, not 60, about 40 something, basically 40 something. If we take the ratio 20 to 40, you will get something like 1 ratio 2 point something. Approximately we can say 1 ratio 2. Okay, so it means that at that temperature, that's 300 Kelvin, okay, it means that Y, the solubility of Y is about 2 times the solubility of X. Okay, about 2 times the solubility of X. Alright, we have a question here on thermochemistry. Tiosulfate 6 acid is prepared using a chemical reaction here. Given the heat of formation for the tiosulfate, water and sulfuric acid as minus 395 kilojoules per mole, minus 196 kilojoules per mole, and minus 811 kilojoules per mole respectively, the enthalpy change accompanying this reaction is, alright, the enthalpy change of a chemical reaction is the heat of the product minus the heat of the reactant. Okay, the heat of the product minus the heat of the reactant. Now in this question here, the heat of formation of the sulfuric acid, okay, is this here. Alright, minus 811 kilojoules per mole. Alright, that will be the heat of the product, while the heat for the reactant is the heat of this tiosulfate here and water, which is what we have here, minus 295 and minus 286. So we find the sum of these two here. The sum of these two, we have minus 395 plus minus 286. Plus and minus is minus, so here we have minus 395 minus 286, and that will be minus 681. So our enthalpy change now, or what we call the heat of formation, is going to be equal to the heat of the product, the heat of formation of the product, which is minus 811, minus the heat of formation of the reactant, which is minus 681 here. So you have minus times minus again here, that is plus minus 811 plus 681, that will give us minus 130 kilojoules per mole. That is the enthalpy change accompanying this reaction. Next question on chemical bonding. In 2 separate experiments, 0.36 grams and 0.71 gram of chlorine combined with a metal X to give Y and Z. An analysis showed that Y and Z contain 0.20 grams and 0.40 gram of X respectively. The data above represents the law of, the data we are given there represents the law of multiple proportion. Okay, the law of multiple proportion, which says that if two elements, okay, if 2 elements can combine to form more than one compound, okay, if 2 elements can combine, like the chlorine and X here, can combine to form more than one compound, the masses of one of the elements that combine with a fixed mass of the other element is going to be in ratios of small whole number. Okay, if you look at two, let's say for example nitrogen oxide here. Okay, this nitrogen oxide here. Okay, so if you look at this one, you see that a fixed mass of this nitrogen here combines with, like, say 1 mole of oxygen. The atomic mass of oxygen here in this compound is 16. Here it is 32 because we have 2 of it here. If you look at the ratio of oxygen in NO2 to NO, we have 2:1, that is 2, which is a simple O multiple ratio. Alright, that is the same thing here too, in that if you look at the ratio, okay, if you look at the ratio here is 0.4 divided by 0.2, this is 2, which is a multiple, like a simple O multiple ratio. Next, if an element X of atomic number Z and mass number Y is irradiated by an intense concentration of neutron, the relevant nuclear reaction is. Alright, this is what we are going to get, this B here. Okay, chemical reactions, they follow the law of conservation of mass. What that means is that the sum of the atomic masses here must be equal to the sum of the atomic masses here. The sum of the atomic numbers here must be equal to the sum of the atomic numbers here. So if you look at the sum here, y plus 1, that is y plus 1, x plus 0, that is x. So this is a balanced equation. But if you look at the other one, it is not so. Y plus 1 is not equal to y, z plus 0 is not equal to z plus 1, and you find the same thing too in the other ones as well, like y plus 1 here, you have y minus 1, which is wrong. Z plus 0 should be z, not z plus 1. Okay, and here z plus 0 should be z, not z minus 1. So this is the correct answer here. Okay, this is the correct answer here. This is a balanced equation for that reaction between the element X and the neutron. Next, a vapor density of a gas may be defined as, that is the mass of a unit volume of the gas compared to an equal volume of hydrogen. Okay, the density is mass per unit volume. The vapor density is the mass of a unit volume of a gas. The vapor density of a gas is the mass of a unit volume of the gas, that is the mass of 1 dm cube. Okay, the mass of 1 dm cube of the gas compared to 1 dm cube of hydrogen. So look at, okay, what is the mass of 1 dm cube of the gas and what is the mass of 1 dm cube of hydrogen. The ratio there is what gives us the vapor density of the gas. Next, on gas laws, 30 cm cube of oxygen at 10 atmospheric pressure is placed in a 20 cm cube container. Calculate the new pressure if temperature is kept constant. Alright, so here we are going to be applying Boyle's law. Okay, Boyle's law, because this has to do with varying volume and pressure at a constant temperature. Alright, so we're using the Boyle's law. From the Boyle's law, we have P1 V1 to be equal to P2 V2, where what we have here, the P1 V1, they are the initial values of our pressure and volume, and these are the new values of our pressure and volume. Now the question with 30 cm cube of oxygen at 10 atmosphere. So this is the initial volume, okay, and this is the initial pressure. It is now placed in a 20 cm cube of container. Okay, that means the volume now is going to, the volume has changed there. So you have to calculate the new pressure if the temperature is kept constant. Okay, and as we know, gases, alright, they basically fill up their container. So when this oxygen is now placed in this container, that means that its volume, okay, it will now reduce to this. So this will be the new volume. We are now looking for the new pressure, this P2 here. If we make P2, to make P2 the substitute of the formula here, we are going to divide both sides of this equation by V2. So we are going to have P1 over P1 V1 over V2 is equal to P2, or as we have it here. So our P1 and V1 are initial pressure and volume, that is 10 times 30 divided by the new volume, which is 20. 10 times 30 is 300. Next, on matter, a liquid begins to boil when, that is when its vapor pressure equals the atmospheric pressure. So at the boiling point, okay, the vapor pressure of the boiling liquid is going to be equal to the atmospheric pressure. 4 elements W, X, Y, and Z have atomic numbers 2, 6, 16, and 20. respectively, which of these elements is a metal. So in the periodic table, we usually find metals in group 1 and group 2, and sometimes we also find them in group 3 as well. So what we need to determine from here is which of these elements belongs to group 2, group 1, 2, or 3. To get that, we are going to write the electronic configuration of these elements using the KLMN. Okay, the KLMN configuration of this electronic configuration of this element. For W with an atomic number of 2, that will just be 2. For X, we are going to have, which has an atomic mass of 6, we have 2, 4 for its KLMN configuration. For Y with an atomic number of 16, we are going to have 2, 8, 6. For Z, we are going to have Z has an atomic number of 20, we are going to have 2, 8, 8, 2. Now, how do we determine the group to which these elements belong? Is by looking at the last number in the configuration. Okay, the last number in the configuration. So you see that W here has 2 here. Okay, has 2. However, now it's supposed to be in group 2. It's supposed to be in group 2. But if you look at this 2 here again, also means the atomic number, as is this one, because of the atomic number. If you now think which element has the atomic number of 2, that is the helium. Okay, the helium in the periodic table, where is the helium placed? It is placed in group 8 or 0. Okay, group 8 or 0. So helium there is regarded as a noble gas. Okay, it's a noble gas, not like the other elements in group 2, the alkali, the alkali earth metal. So we say this W is not there. Okay, and if you look at the other one, X is in group 4, which is not a group of metal. All right, group 6, no. But if you look at this 20 here, okay, it has the last number in the configuration here is 2, meaning that this element here belongs to group 2. Okay, so this X belonging to group 2 is going to be a metallic element, because group 1 to 2 elements, they are metallic. Group 1 element and group 2 elements, they are metallic. So here, except for hydrogen in group 1, so this element Z here is going to be a metallic element, so it will be a metal. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next, when cathode rays are deflected onto the electrode of an electrometer, the instrument becomes. So cathode rays are streams of negatively charged particles. They are streams of electrons. When they are deflected onto the electrode of an electrometer, that instrument is going to acquire the negative charge. Okay, it will acquire the negative charge, so it will become negatively charged. Next, on organic chemistry, right? When large hydrocarbon molecules are heated at high temperature in the presence of a catalyst to give smaller molecules, the process is known as. It is called cracking. Cracking is the breaking down, okay, or the breakdown of large, heavy organic molecules or hydrocarbons into simpler or lighter units under heat, pressure, or the presence of or the addition or use of a catalyst. So that is, if concentrated sulfuric acid is added to sugar and warmed gently, the sugar changes from white to brown and finally to a black mass of carbon. In this reaction, concentrated sulfuric acid is acting as the sulfuric acid here is acting as a dehydrating agent. Now this process here is what is called charring. Okay, this is charring. It is a chemical process where an organic solid, okay, containing carbon undergoes incomplete combustion to give a black, a black surface. All right, during the process, you can concentrated acid can be added. All right, and there it acts as a dehydrating agent. It dehydrates the cellulose in that given organic compound, say a wood for example. So it acts as a dehydrating agent, dehydrating the cellulose in that wood. Next, on solutions, Smoke consists of solid or liquid particles that are dispersed in gas. In the electrolysis of dilute sulfuric acid using platinum electrodes, the products obtained at the cathode and anode are, alright, in the electrolysis of water, okay, or dilute sulfuric acid, alright, at the anode, oxygen is obtained at the anode, while hydrogen is obtained at the cathode. So what happens is that in that process, the hydrogen, which is positively charged cation, it will migrate to the cathode where it will be liberated, alright, as a gas, while the oxygen, okay, is produced at the anode. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2 or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. Alright, which of the following will increase the yield of R? So this reaction here is an exothermic reaction, in that our delta H here is negative. Okay, the enthalpy change is negative, and you have that in an exothermic reaction where it is lost. Now the question is, which of the following is going to increase the yield of R? That would be removing some of this here, some of this S here. When the species on one side of the equation is removed, the equilibrium is going to the equilibrium of that system will be altered. Okay, the system is going to adjust so as to produce more of that substance that has been removed. Okay, so it will shift to that side of that substance that has been removed. So it will increase the yield of R, which is on this side. We can just remove this. Okay, we have this on the same side as R, so removing this from this is going to increase the yield of R. It will shift the equilibrium position to the right. Next, on electrochemistry, the mass of silver deposited when a current of 10 ampere passed through a solution of silver salt for 4,830 seconds is. Alright, so the oxidation of silver, the oxidation of silver is +1. Is +1. That means that to liberate 1 mole of silver, we are going to need 1 Faraday of electricity. Okay, 1 Faraday of electricity, and that 1 Faraday of electricity is 96,500 coulombs. Now that 1 mole of silver that this 1 Faraday is going to liberate is 108 grams. Now so that will be the quantity of it that will liberate 108 grams of silver. If you now have 10 ampere of current passed through a solution of silver in 4,830 seconds, then what we are going to do is we will calculate the quantity of heat there that has been supplied to that solution, and that will be equal to the current times time. That is 10 times 4,830, and that will be 48,300. Then we are going to set up a ratio here. Okay, that 1 Faraday of electricity is equal to 108. Then let this quantity of electricity that is produced with what we have here, okay, let that be equal to M. That is the mass of silver deposited that we are looking for in the question. We represent it as X, as M rather. So we say 1 Faraday or 96,500 coulombs of electricity produce 108 grams of silver. 48,300 is going to produce M. Then we are going to set up a ratio here. 96,500 divided by 48,300 is equal to 108 divided by M. Then we cross multiply. If we cross multiply, this M comes here, so this becomes 96,500 times M. So we have this, and on this side you have 108 times 4,000 and 48,300. So on this side we have 5,216,400. To get the value of m here, we are going to divide both sides here by 96,500. 500. So dividing both sides by 96,500, we have m to be equal to 54 grams. So that means that this quantity of electricity is going to produce 54 grams of silver. Next on chemical equilibrium. From the reaction above, calculate the standard heat if the standard enthalpies of formation of carbon monoxide, water, and carbon dioxide are as given here respectively. The standard heat change or the enthalpy change is going to be the heat of the product, which here is carbon dioxide, minus some of the heat of the reactants. Alright, so you have that to be the heat, the enthalpy of carbon dioxide, that is minus 394, minus in brackets the enthalpy of water, that is minus 242, plus the enthalpy of carbon monoxide, which here is minus 110. Okay, so you have minus 242 plus minus minus there is minus, so you have minus 142 minus 110, and this will be minus 352. Then here we have minus times minus, that is plus, minus 394 plus 352, and that is minus 42 kilojoules per mole. Next question: if the electronic configuration of an element is 1s2, 2s2, 2p6, how many unpaired electrons are there? Alright, a very fast way to do this is to draw the orbitals. Okay, the orbitals for this. Now if you look at this here, this element here is fluorine. How can I tell that it is fluorine? What I can do is find the atomic number of the element that has this configuration. How do you get the atomic number of an element when they give you the SPDF configuration like this? Just add up the powers that you have here. Okay, if you add up the powers, then now 2 plus 2 plus 5, that is 7. That means that the atomic number of this element is 7. Then if you look at your periodic table, which element has the atomic number of 7? That is fluorine. Alright, fine. Now this is the orbital configuration for it. So you have the 1s2, 2s2, and 2p5. You can see that the electrons in these orbitals, they are in pair. But if you look at this orbital here, we have one unpaired electron. That is one electron that is not in pair. So this element here has one unpaired electrons. Okay, one unpaired electron. Next, which of the following gases can best be used for demonstrating the fountain experiment? That is ammonia and hydrochloric acid. Ammonia and hydrochloric acid, they are used in the fountain experiment. The colored nature of transition metal ions are associated with their partially filled d orbital. Okay, now the incompletely filled subshell, the d and f orbitals, account for some other properties of the transition metals. Of course, one of it is this colored ion. Okay, the formation of colored ion in compounds is also due to the incompletely filled orbital as a result of the transition of electrons. Okay, transition of electron between the orbitals. Also, formation of complex ion and their action as a catalyst in many reactions, and the formation of paramagnetic compound. These are some of the properties of transition elements. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry, and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry, and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Scholar Edu. Okay, like and share our content, and visit our website at scholar.com to practice UTME exam and modular quizzes for free. Thank you.